Welcome to my YouTube channel. My name is Yohana Muhammad. I'm a student of Maki University. I'm doing software engineering. I'm here to present a project about AI. So in our project, you are going to see how to use AI to predict heart failure. In our introduction, you can say that artificial intelligence is revolutionizing the world on many levels. Based on our AI project, we can see how AI can be used to analyze heart sounds and predict heart failures using machine learning algorithms. We will see the ability of artificial intelligence. Our task is to answer to the question, can computers think? And the second question is, could we ever have a computer that is able to think? We are going to use some theories to bring some answers to that questions and see the limits of AI on health context. So the first question is, can computers think? Our AI is designed to analyze heart sounds such as heartbeats to predict heart failures. It uses techniques such as spectral analysis to process audio data. It is trained on heart sounds datasets so that it can identify abnormal patterns related to heart failures. She has a great ability to detect correlations, but it should be noted that she doesn't understand either the medical context or the emotional implications, unlike a doctor. To do this, an important question is added. Does it think like a human, or does it focus on executing and following rules that have already been programmed? So you are going to see those different and several theories to bring some answers. You have here a strong and weak AI. There are two types of AI. Yes, you have the strong AI and the weak AI. The strong AI has a general thought consciousness like a human being, whereas a weak AI is designed to precise a specific task. Our AI here is a direct example of a weak AI. It performs a very specific task, which is to predict heart failures through calculations. This is why we say AI detects sound abnormalities but does not reason like a real doctors interpreting the global context. It operates without consciousness or intentionality. Then, according to the Chinese room argument, claims the artificial intelligence is able to produce correct data without understanding its true meaning, like a person using Chinese signs or symbols without understanding the Chinese language. Our AI is able to analyze heart data and be able to predict heart failures, but you should know that it follows already fixed programs. It is unable to understand what a disease or a heartbeat is. This is why we speak of intuition and consciousness. It works programmed to knowledge but devoid of intuition and consciousness. It processes data but without meaning. This argument once again raises our question, can computers think? Then our next slide talked about the mathematical mind and those 8 types of intelligence according to Gardner. So the concept of mathematical mind talked about the ability of a human or an AI to be able to solve problems, obtain solutions through algorithms, logic. However, thinkers such as Goddard and Panzer demonstrate that human thought is vastly superior to formal systems because it holds consciousness, creativity, and intuition. AI gives precise but limited calculation simply because it is programmed. That is why Panzer says human thought goes beyond formal systems. In the same vein, there is a theory of limits of formalizations. According to Goddard, some aspects of our thinking cannot be totally formalized in a mathematical system. Then you are going to see those eight types of intelligence according to Gardner. We have the logical, mathematical, linguistic, spatial, musical, corporeal, kinesthetic, naturalistic, intrapersonal, and interpersonal. These different intelligence make it possible to compare the capacity of AI with the thinking of human beings. Musically speaking, AI is able to detect the rhythmic patterns of heart sounds, but unable to appreciate their beat. In the intrapersonal order, AI is not able to interact or understand the emotions of a patient as a real doctor. In the same vein, there are the theories of learning versus memorization. AI learns thanks to the data set, but it looks more like statistical memorizations than intuitive and creative learning. We also have the theory of intuition and consciousness to make us understand that AI lacks intuition and consciousness in order to improvise in the face of an unusual case unlike a real doctor. Then you are going to see the second question is, could we ever have a computer that is able to think? Given technological advance, we could hope to see an AI one day able to imitate the idea of a man in a very coherent way. In our case study, we could have a future AI capable of combining classical approaches to be able to manage complex contexts, such as a patient's medical history. However, one problem that remains relevant is that AI will always struggle to detect important data in various medical scenarios, something that the real doctor intuitively do. Thanks to the progress of science, we could have an AI capable to surpassing humans in the accuracy of diagnosis, but without consciousness, it would not be really think. A truly thinking AI in our medical context will always face significant philosophical and technical challenges. We will use existing theories to debate our questioning. We have what is classical and connectionism. So the classical is more based on explicit logical rules, which are less flexible but well structured. Connectionism, on the other hand, is based on neural networks. Our AI here uses a connectionist approach to be able to analyze heart sounds. A future AI could combine the classic rules to better manage more complex contexts, such as being able to integrate a patient's clinical history. A fusion of these two approaches could make AI robust and capable of performing unexpected tasks, but will always remain not thinking. Then you have the frame problem. The frame problem, this one highlights the difficulty of an AI to determine what information is relevant in a complex context. Humans intuitively solve the frame problem, whereas an AI needs more advanced mechanisms to achieve this. These different approaches can improve the performance of AI, but without awareness, it would not really think. That is the important part. Then you're going to see what is a simulation argument and superhuman intelligence. Nick Bostrom says that we could live in a simulation created by AI, but this raises a very important question. Can it simulate human thought while including consciousness? Future AI may have more performance, it will remain without consciousness, which is why in our project here we will say that a more efficient AI will be able to give precise medical diagnosis thanks to the heart sounds provided, but without consciousness, it will always remain an unadvised imitation. Then for the superhuman intelligence, which describes an artificial intelligence capable of suppressing humans, but the problem still remains unsolved because AI will always be devoid of intuition and consciousness. In our conclusion, we are going to say that in view of all that we have had to evolve, we can say that AI does not really think, it excels in very precise and specific tasks. A future AI may well simulate more intelligences, such as interpersonal intelligence, and become a super intelligence. But the frame problem and the limits of simulations remain a major challenge for AI. Our AI will be able to analyze heart sounds, in future AI will even be able to integrate contextual data, but will always remain unconscious. Dash in spite of this, truth road faces philosophical and technical obstacle. So in other words, we can say that, to resume our work, we can say that AI can be improved, but it can never think like a human being. It cannot. Thank you to listen to my project. That is the end of the project. Thank you, everyone.